All right, welcome to the very introductory beginning of statistics. That will include some sampling ideas, some data, and we'll end with some bar graphs. So bear with me on this one. When you are dealing with statistics, you typically are interested in getting data about individuals. Those individuals can be people, but they can also be items. Like you might be interested in the weight of candy bars that are coming off of your assembly line. So you're not always interested in about people, but whatever you're interested in, you're generally interested in about a large population of individuals. And in statistics, we are going to try to answer questions about the population based on a sample. So being able to differentiate between a population and a sample is very important. The population consists of every single individual or member of the group. Often it is difficult to reach out and get information from every single member of a group. It can also be expensive. In the United States, every 10 years they attempt this with something called a census, and that is happening right now in 2020. So because of the population's difficulty, even if you think about making candy bars, Snickers bars, or whatever, there's thousands of candy bars, and it would be difficult to weigh every single one. So instead you would choose a subset of that population, and you would find out information about the subset, and you would hope that it would then represent the population you were interested in. So a sample is a subset of the population, and it will give you information about the population, whatever you're trying to measure, whether it's heights or candy bar weights or eye color, doesn't matter. It will give you information about the population as a whole if it's done correctly, if it's representative of the population, and if it's free of bias. So those are things you want to try to make sure you get done. So if you want your sample to be representative and proper, you will do it correctly. It is representative only if it actually represents the population that it's chosen from. And if you want to eliminate that bias, you need to be very cautious. A bias happens whenever you accidentally or purposefully exclude particular members of a population. Therefore, their values wouldn't be counted in what you were measuring, and therefore your sample would misrepresent the population of interest. And there's a lot of ways bias can creep in. It can sometimes be the way you word a question. If you're asking a question on a questionnaire, it can be a way you distribute a survey. It can be how you pick the individuals in your sample. All of those things can lead to bias, which leads to misrepresentation. So we are going to focus on sampling techniques. These are the 5 that we're going to focus on. Convenient sampling, simple random sampling, which I will refer to as SRS from now on, systematic sampling, stratified, and quota. And if you can layer a couple of these together, it's an even better sampling technique. And as long as you have some form of randomization in your sampling, you're doing a good job at sampling. If you have no randomization in your sampling method, then you're kind of not going to be representing the population of interest properly. So convenient sampling is the first. I'm going to read through these, but obviously you're taking notes, so if you need to pause and just write these down, or this is always a reference to go back to, so that's kind of up to you. There's a lot of terminology in the beginning of stats. So it's obviously the easiest because you just pick whoever is the most convenient. That's why it's called a convenient sample for you. So for example, if I were trying to do some information about students, the easiest thing for me to do would be to just ask the kids in my classes, because I see them on a regular basis, and that's the easiest one for me. For you, it would be your friends or family members, and so if you're interested in how much time people are spending on Netflix, you would just ask your friends. But is that representative of the population of all teens watching Netflix or all families watching Netflix? Not necessarily. So you have to be careful with convenient sampling. It's actually a pretty poor sampling method. A simple random sample is the best when every member in the population has the exact same chance of being selected in the sample. It's often not easy, and there are other ways to modify it to make it better for what you're trying to find out. But an SRS is the purest technique for sampling. An example would be if I wanted to just sample from my own particular class, I would just put all the students' names in a hat and draw like 5. And then I got a sample of 5. I had no decision in who was chosen. It was all random based on how they were in the hat. If you want to do it more professionally, every member in a population would be assigned a number. and then you would use a random number table or random number generator to select your sample. And just as an example, it's a little blurry, but this would be a table of random numbers. So as you can see, they just kind of go across, and basically there's no pattern to any of these digits. So if I had 30 kids in class, I'd give them all a number like 0, 1 to 30, and then I would go through, and so 61 would be the first number. I wouldn't have a student labeled as 61, so I'd skip it. 42, no student there. 42 again, but then 04 means the fourth kid in my list, probably alphabetical, would be the first person in my sample. 19, that means the 19th kid in my list would be the next student sampled. I would have to skip 86, 54, etc. And then 05 and 17 would be the next two students in my list, because my population was only 30 that I would draw. And you just keep going. And if I ended up finding 05 again as I went through this, I would just ignore it a second time because I already had that kid. So that's kind of how random number table. And again, as you can see, this I just pulled up off the internet. I have no idea what order those numbers are in, so I have no personal choice or matter in the selection process. A systematic sample is similar to random, and except for that, before you do your sampling, you would break your population into groups called strata. And oh, sorry, this is systematic. I'm jumping ahead of myself. Systematic is when you would randomly use a digit or some other random way to initiate the process of sampling, and then you would continue picking your sample from a fixed system or interval that you had in place. So systematic is pretty easy to identify when it shows up. If I alphabetize my class list, and then I just use that same random number table and pick the first single digit from 1 to 10. So if I go back to that very quickly, the first single digit would be 6. So that means I would start with the 6th kid in my list, and then every 5th student after that I would also choose to be in my sample. So the 6th kid in the list, then the 11th, then the 16th, etc. That's systematic because it's a system. Stratified, which I started to explain earlier, is when you take your population and you divide it into groups before you choose your sample, and you would choose those groups because they had some kind of shared characteristic. Often it's gender, it's like males and females, and then you choose from the males and the females. Could also be any characteristic that you wanted to separate your population on. But the key is, after you break it into the groups, then you choose a random sample from each group and combine them together for your sample. So again, if I wanted 100 kids from the high school, I could then randomly choose 25 from each of the graduating classes, and I would have a total of 100, and I would have a representation from each class. Which leads us to quota sampling, which is like stratified, except for that after you break it in your groups, you might recognize that your groups are different sizes, and so you want your sample to be representative or proportionate to the size of each of those groups, because they're not always equal. So I just looked up some numbers on New Hampshire. If I want to sample 1,000 people from New Hampshire, and I would break maybe New Hampshire into the counties, I looked up Hillsborough County has about 30% of the population of New Hampshire residing in it. So if I'm sampling 1,000 people, 30% of those 1,000 I would want to pick from Hillsborough County to be representative. So I would randomly pick 300 people from Hillsborough County, and I'll do something similar with each of the other counties in the state. So here are some examples. You might want to pause this video, read these 4 examples, and after you've read them, you're going to decide which of the types of sampling methods they are. So pause video, check them out. Video's on pause. Here are your answers. Again, pause the video, read them. It kind of gives a little explanation as to why each one happened to be what they were. On your homework that you're going to do for this, sometimes there's not enough information. This is pretty thoroughly explained, a lot of information, so it's a little bit easier to identify. If there's not a lot of information, you might have to choose between a couple of them. You might not be able to tell, so keep that in mind. That's a possibility when you're doing your homework. All right, once you collect your data, so you know who you're going to collect data on and what you're going to collect, and then you're going to go out, you're going to get that data, you're going to have a bunch of numbers, and you hope it's reliable. It is if you could repeat the process in which you collected it again and have similar answers or similar findings. You would not expect them to be identical, but they would be similar. And if you have a sufficient amount of data, meaning you have enough data to really reflect the population you're interested in. If you have any missing data due to a non-response, people may not want to answer a survey or a questionnaire. You may not be able to find them, and if you may pick them for your sample and you can't locate them, you can't get information from them. And if there's any kind of errors in handling the data, putting it in a spreadsheet, you leave off a digit, you actually forget to put a piece of data in. As you're recording data, you record it wrong. Anything like that could also lead to unreliable data. We are going to focus in this course on two types of data. Discrete data, basically in general, can be counted, and since it can be counted, it has distinct values, and so when we will notice that maybe like 1, 2, 3, 4, you're not talking about a 1.5 or 2.5 or 3.5 or 3 3/4. Examples would be the number of pets you have in your house, the number of siblings. Some of these questions were on your questionnaire that you already filled out, number of states you visited, those kind of things. Continuous data is typically something that is measured, like your height, your weight, and it is not restricted to fixed values because there's a continuum or a continuous range of values it can take. So we're talking about all the decimals and fractions and whatnot in there. Examples would be the mass of an object, your height, how long it takes to get to school, your GPA, because you don't just have a 1, 2, 3, or 4. It could be 3.57, so that's a continuous data. So again, pause, read these, take a pick. Which of these is continuous? Pause. Okay, there you go. That is diameter. These are countable. T-shirt size, that's not really a numeric variable anyway. But if you take AP Stats, you will learn about categorical variables, and that would be one of them. All right, so we're just going to look very quickly at how to graph a discrete data today only, and we'll look at continuous data later. These are your steps. The keys are that you're going to list them, or you'll be given a list, and then you want to count how often each value or outcome occurs, make a table out of that, and then you're going to graph, putting the values that are possible for your outcomes on the x-axis, and then the y-axis, the vertical one that goes up and down, will be the actual counts, the frequency of each of your possible outputs. And the key on a bar graph is that when you do it, is you're going to leave gaps. So this is a bunch of data. I think there's 32 quiz scores that you could have gotten anywhere from 0 to 10, and they're listed there, pretty horrible. So I made a table out of them. Over here, this is a frequency table. One person had a score 0, 2 people had a score 1, 3 people had a score 2, etc. You notice the 6 people having a score 7 was the biggest, most often occurring score. And then again down here at the very end, this is just how many people had scores of 1 or 0 through 10. And then would graph those. So here's 0 through 10. Those are the possible scores. And then the bars are reflecting how frequent those scores occurred. So that's why they're all as high as they are. So 7 is the highest with 6. I'm very quick to look at this and be able to tell that 7 and 5 were the biggest outputs for scores. You can also kind of see that there were, it's kind of pulled over here to the left with a lot of low scores, but frequency on those low scores is a little bit lower. Here's where the bulk of my data is. All right, I know this was all very quick, and I apologize, but the beauty of this video is you can go back, rewind, slow down, pause, write stuff down. Again, these are your directions on how to do it, and I want you to pause the video. This is data I collected on the last year's class of how many siblings they had. So it's not a ton of data, but I would like you to pause the video, make a frequency table, and then a bar chart. I did mine using technology, but you can also do them by hand at this point. So don't worry about having to use technology. When we look next class on how to do the other type of graph for continuous data, you will be able to use your calculator to make a graph, but your calculator won't graph this type. So pause the video, try this, and then give it a look. So pause. All right, and this is my table, and this is the table with the bar graph. And again, you can see in this particular class of kids I had, 13 was the most, the highest frequency of people who had only one sibling. And that is it. I hope you are able to get something from this, and you have a wonderful day. I'll see you later.